Good evening, everyone, and welcome to Dome at Home for Thursday, February the 17th, 2022. Just someone please let me know that the microphone is working. I had some audio reconfiguration stuff I had to do. I had to do a bunch of tests. I hope it's all working. Hopefully you can all hear me out there. It's great to see folks checking in. We're up over 50 viewers already, and I started saying hello to people and then ran out of speed and fingers to get it all done. We've got Christine from up in Dauphin, Davidian's here, Sheldon Ulrich is here from Winnipeg, Tiffany and Hollis. Oh, nice to see you. Oh, Melissa from the West Coast. Lou is here. Janet is here. Oh, sound is good. Excellent. Thank you. Callie from Swan River. Hey, great to see you. I think we're competing for, coldest part of Manitoba right now. We were down around minus 43 with the wind chill this morning, at least according to the weather forecast. It didn't feel actually that bad today, believe it or not. For those of you in Winnipeg, it is pretty cold, but maybe it's just that I've lost all feeling in my body from the cold temperatures, but it has definitely been a chilly one. Oh, great to see everybody checking in. We got a good show for you tonight. We're going to be looking at exploding stars, or as they are called in the biz, supernova. Basically, some of the biggest explosions that happen in our galaxy. And we will not only talk about them, but also be able to track down the wreckage of one of those supernova that exploded nearly 1,000 years ago. And you can still see the glowing cloud of debris left behind. All right. We will, Sheldon, you're out in Gladstone. Great to see you. I've spent a number of times out in Gladstone. I used to take the mobile planetarium, the inflatable dome, out to Gladstone, usually once or twice a year, and visit all the schools in town and stuff like that. So that was fun. Great little spot. And what's the name of there's a little restaurant like right on just off the highway that I ate at 4 days in a row. That's just wonderful. Anyway, I don't know if it's there anymore, but, let's see. Krishna is here from Texas. Lou's in San Vital. Excellent. Okay. Let's get started. Sorry if I didn't get a chance to say hello to you. I'll stick around at the end and we can chat a little bit. I love how the community from this show has sort of just taken on its own life, and you guys are talking to each other and answering each other's questions and stuff like that, sort of in parallel to the show. It's really nice to see. So I'd like to just hang out in the chat for a little while and not have to do the show sometimes. So anyway, we'll see how we can do that. Okay, let us move into our content. As you all know, we're broadcasting from Winnipeg, Manitoba, through the Manitoba Museum here in Treaty 1 territory, and the museum is reopened. We're open Thursday, Friday, Saturday, Sunday. The planetarium right now is only open Saturday, Sunday, and we've got the new show Magic Globe going on. We also have, I just locked the schedule today. We have a brand new show that will be opening for spring break, which here in Manitoba is the last week of March. That weekend, the Saturday before spring break, we'll be opening a brand new show. Now, if you've been counting, that means we opened a new show in February and a new show in March. That's pretty unheard of for us. Usually we have a long time between show openings. Next week, we'll talk about that show and give you maybe a sneak preview. So you'll get a chance to see what the new stuff is coming up there as well. Let's see. Randy asks, you have an inflatable dome. We have one. It hasn't been used for a number of years because I kind of used it into the ground. It requires quite a bit of repair, and the projection system is, pretty old school. It's not like a digital system. So we kind of retired it. It actually became very expensive to drive around the province and do these programs, unfortunately. And we tried ways to, send it to schools, but they weren't comfortable setting it up. It was a complicated thing to run. And once sort of the grant funding ran out for that program, it sort of faded away. We'd like to do more outreach like that, but we're finding actually now our outreach has gone on to Zoom, and we're doing a lot of programs for school groups both in-house, but we're also doing them virtually. Like we just did a school group in actually in northern BC just today, did one of our school programs. And I had a class that was up in the Yukon actually doing our school programs a few weeks back. So we have that kind of outreach going on right now. Okay, we will talk about one more thing. I mentioned these last week a little bit, but I want to plug them again because now the information is out. We are running Dome at Home courses. So we're basically trying to take some of the questions that we see in chat, some of the common questions that we see over and over again from different people, and put them into kind of a format so that you can watch the course and then sort of have a certain aspect covered. So we've got 3 introductory courses, and so those start in March, and they're getting to know the stars, which is kind of constellations and motions and finding your way around. There's binocular astronomy, and then there is choosing a first telescope. And there's each of those is available, and then you can actually get a deal if you sign up for all 3 introductory ones. We've got some intermediate ones. This is new for us. We haven't run really the more advanced courses for quite a while. The new telescope user's guide I'm really excited about. It's kind of how to get your telescope from the box to actually doing what it's supposed to do. Because often the instruction manual is less than complete, or there's some tips or tricks that just aren't covered in the manual. Some of this will be, from the book Night Watch, but a lot of it will be from the School of Hard Knocks. I had a telescope when I guess I was about 14 or 15, and the tripod gave me a huge amount of trouble. And I figured out from first principles a bunch of ways to improve the stability of my tripod, and it made my telescope much more usable. We'll talk about finder scopes, we'll talk about eyepieces, all that kind of stuff. Melissa, there is a bundle rate, although apparently the bundled rate was not programmed in last week. It just got resolved today. There's some kind of coupon discount issue in our ticketing system. So it is on there today. Tickets.manitobamuseum.ca is where you can get registration for all those courses. The April and May courses, like I say, they're the intermediate level. There's a bundle for those as well. Observing the moon is not just sort of like going and looking at it, and it's not just the lunar phases. It's really sort of a geological tour of the moon as seen through good binoculars or a small telescope. So we're not just going to be looking at stuff. We're going to be making observations of the moon and figuring out what that actually tells us about the history of the moon and the formation of the solar system. So it's kind of taking that next step from just looking at things that are cool and trying to figure them out based on what you see. And then observing the deep sky is all about those fuzzy, faint objects out beyond the solar system. Galaxies, star clusters, nebula. We've talked about a few of those, the brighter ones, but there really are some tips and tricks, again, that will help you get the most out of your telescope and increase your rate of success for finding those things. They can sometimes be a challenge to track down, and once you track down and get to the right spot, they can be a challenge to really wring every photon of light out of that image so that you can see what's going on. So I look forward to seeing some of you in those classes. I know a few of you have already signed up, and I understand that the first couple of them are already not sold out, but close to sold out. We're only taking 25 people because I want to make sure it's a little more intimate and people have a chance to answer questions. I don't want to have the chat go by so fast that I just can't keep up. So that's coming up, and we have some images that were sent to us this week. I don't know if anybody was out at sunset last night. I was driving home. Actually, I picked up my kid from school. We're driving home on Fermor towards St. Mary's, and the moon was right there, and it was massive. We both, at the stoplight, started taking pictures. They got the better one. Now, it doesn't show, the picture doesn't really show the true perception. When you take a picture, it's a direct representation of what you see. But when you're looking at it with your eyes, there's something about the moon that makes it really, really big at the time that it's rising. Now, it's not actually big. If you hold your pinky finger up at the end of your hand and hold it towards the moon, you'll actually see that the moon is smaller than your pinky finger. And when you do that, when you have that reference, the moon almost looks like it shrinks down. As soon as you take your finger away, though, the moon just balloons up. There's something that happens between our eye and our brain that makes us perceive the moon as bigger than it is. And it only happens near the horizon. It's a part of the universe, like it's not that the moon is actually bigger. It's not that it's being magnified by the air. It's not closer to us or anything like that. It really is not bigger, but our brains tell us that it is. And it's something that neurologists do not understand. There's a few interesting ideas, but we really don't understand. It's very powerful, the moon illusion. Tonight and tomorrow, you'll get the same kind of opportunity if you get a chance to get out there when the moon is just rising and catch it very well. This was just sort of a blow up, and this kind of conveyed the view just because the fact that you've got the apartment building there and it looks pretty small compared to the moon. But like I say, you kind of had to be there. This is a picture I just got. Melissa sent us the first picture through their new telescope. And I got to say, that's pretty impressive. Nice full moon there. You can see that along the bottom, you've got still some craters that are just visible with the shadow and things like that. You've got the dark areas and the bright areas, some of the big craters. And so there's a few questions that Melissa asked. I didn't get a chance to send the email because I literally saw this just before we went to air. But the ring around it, that's probably something that to do with the either the cold. I'm not sure how cold it's been out for you, but it can also be a little bit of reflection. The moon is so bright that there's just so much light there that any dust on your telescope optics or any kind of reflection or any kind of humidity in the air or anything like that can really just bounce all over the place. It's not bright enough to be dangerous. It's totally safe to look at the full moon, but it can be uncomfortable sometimes. It just really is very, very bright. If you have a pair of sunglasses, I find that that's a perfect filter to look at the full moon with. It just cuts the light out just enough to make it a little bit more comfortable. I mean, you can buy a moon filter, but you probably already have sunglasses, and they're literally the same thing. So great shot. Thanks for letting us use that. I love the fact that this is like your first picture. And I bet, a couple months from now, you'll take another picture of the moon and you'll be able to put them side by side and be blown away at how much you've learned just by doing it a couple of times. I mean, this is a great first image. And like I say, I can't wait to see what you do next. So, okay. The show tonight is about exploding stars. Before we get to that, though, I do want to do our Stellarium Tour. So let's pop over to the night sky, switch windows here, and we will take a look at our evening sky. Let's see. Wow, lots of comments, lots of questions. That's great. The evening sky is cold. We have had some nice clear skies here in Winnipeg the last couple of nights, but it has been just bitterly cold. And you really have to be careful if you're going outside, even to the point where, it's not great for your equipment or things like that. A lot of my better cameras, I run from a computer, like a laptop, and I'm afraid to leave my laptop out for too long because the liquid crystal display screen, if it freezes, it will split and I'll lose the whole computer. So I'm using just my really basic gear, my camera, my iPhone. That doesn't last very long in the cold either. Binoculars and things like that. And I really wish we get a night where it's only -10 or something, because then I could bring out all the better gear and get some observing in. But still, whatever you observe with, there's lots to see up there. We still have our evening constellations. The Great Square of Pegasus is just setting over in the west. You might, just as it's getting dark, you'll start to see that low over in the west. But as always, the southern sky is the highlights, and we've got, brilliant Orion over there. The belt stars of Orion point down and to the left towards the brightest star in our sky, Sirius the Dog Star. We talked about how Sirius is often reported as a UFO because it's so bright that its twinkling actually is in color, and those colorful flashes, are really eye-striking. The ancient Egyptians actually thought that Sirius was so bright that it would add to the heat of the day, and the sun And the Sirius would rise just before the sun in sort of the middle of the summer, sort of in August. So if you've ever heard of the dog days of summer, the dog days of summer are literally the time when Sirius and the sun are rising at the same time in the morning. And the idea is they're so hot because Sirius is actually adding its heat to that of the sun and making it a hotter kind of thing. Now, we don't actually have any noticeable heat from Sirius. It's far too far away from that. But it does give us insight into the kind of things that people were watching for and the kinds of cycles that we look to the sky to try and explain. So that's pretty cool, actually. I like that story. Sirius, great star to look at. As we move over more towards the east, we still have Gemini the Twins. Oh, I'll pull that down a bit. Gemini the Twins is nice and high. The moon went through Gemini last week and was over near the little star cluster M35 right by his foot over here, and then popped through the middle and was lined up with Castor and Pollux, the two bright stars over there. The moon has since moved on through faint little Cancer the Crab here, and then on to Leo. In fact, you can just see the moon glow at the horizon there, because the moon is probably just about rising, I guess about now, actually. So let me just pop this into live mode, and we'll just see how high the moon actually is. Yeah, the moon is just rising now. So if you have a good view to the east, take a peek, and you should get a beautiful view of the nearly full moon rising with that moon illusion. Up above the moon, we've got the head and then the body of Leo the lion. And up from there, basically, we'll turn over here, sort of up and to the left, that's where our Big Dipper is, over there in the northeast. So we've got sort of our bearings here. Lots of other constellations. With the moon up, you don't see all the fainter stars. It's hard to see even the basic constellations sometimes, let alone some of these fainter ones. Here's, just recently we had a family of 4 lynx cats spotted here in Manitoba near the city. Well, there's a constellation of lynx that is over in this part of the sky over here. I don't know how that's supposed to be a lynx, but very faint group of stars, not one that jumps out. But there's a whole bunch of those constellations. You really need to look at those during the dark period of the moon, though. The only other one I'll point out right now, over in the northwest, Cassiopeia, the Queen, right in the middle of the Milky Way, arcing up over here. You can still see, actually, this is Cygnus in the Northern Cross. That's one of the 3 stars right there of the summer triangle. So we still have that summer triangle, at least partially hanging around. If we zoom out and sort of get a view of the whole sky, this is sometimes a complicated view to look at, but this can sort of give you a sense of, okay, you know, these are the constellations on this horizon, these are the constellations on this horizon, and this is the up direction. This is the zenith, the constellations directly up above you. We're very close to having Capella, the bright star in Auriga the Charioteer, this sort of pentagram shape, at the zenith. And attached to Auriga is this V-shaped group called Taurus the Bull. We're going to look at Taurus again later. If we spin this around, basically this is passing very close to the overhead point. So yeah, Ulrich, Leo coming up means warmer temperatures are hopefully around the corner. Yeah, it really is an indicator that spring is coming. Now, if you went outside right at sunset, you might have caught Jupiter. It's still barely visible low down in the bright sky. But to be honest, unless you've got a clear horizon and really clear sky and good eyesight, Jupiter's probably done for you now. It is basically passing behind the sun, not exactly behind the sun, but close enough that we just can't see it anymore. It's set soon after the sun. In a month or so, it'll pop up in the morning sky. But right now, a lot of things have already popped up in the morning sky. And actually, let's just fast forward to the morning sky over here. There we go. If we look at the sky around about, what time is this? Oh, 6 in the morning or so. Sort of in the southeast, we have the brilliant planet Venus. Brightest thing in the sky. Brighter than any star. Basically, it's just the sun and the moon that are brighter, and that's it. The planet Venus, it looks like it's depicted as if it was big here, but that's because that's the only way we can sort of show something as being bright. We can't really make the pixels on your screen get brighter. So once it's white, that's as bright as they get, basically. So they have to make the thing bigger. But it just looks like a star, but it is brilliant. And down below it, you won't see it at 6 in the morning, but you might see it a little bit later. Let's see if I can get a little bit higher in the sky before the sky gets too bright. As the sky starts to brighten, the planet Mars might pop into view down below Venus. Over the last week or so, the planet Mercury was right over here. It's probably not visible anymore. It's just down too low. By the time it gets high enough over the trees, the sky is already too bright to see it. So I think Mercury's pretty much done for us. It wasn't a great time to see Mercury this time around. We have a better chance coming up in April, so we'll go for that. But that's where all the planets are. And the planet Saturn is actually even closer to the sun right now. So we're losing out on a lot of these planetary hijinks that we were seeing before, with the moon passing the planets and the planets lining up and all that kind of stuff. We'll see more of that as the spring goes on and then turns into summer. As these planets get farther away from the sun, we'll be able to see them earlier and earlier, and they'll become more and more visible, and then we'll be able to see some of the neat things that they do as the moon goes by or whatever. So be patient for those, and we'll have a good chance to check those out a little bit later. Let's see, we have some questions here. Melissa asks, will astrophotography be covered in any of the workshops? In the advanced one, the intermediate ones, yes. We will be talking a little bit about very basic stuff in the binoculars workshop. I've done some successful shooting through the binocular eyepiece kind of thing, but really we'll cover that in the lunar one and the deep sky one. We have, Tiffany's been watching the Churchill Northern Lights live stream. Lots of comments about the snow. Yes, absolutely. And, we saw a really bright star near Castor and Pollux, but it wasn't showing as part of a constellation. Any ideas? Well, if it was moving, I would suggest it was the International Space Station, because that'll sometimes come through the sky, and that is nice and bright. Other than that, though, there really isn't anything that shows up as a stationary star like the other ones. I mean, it's possible that, there was an airplane that was in the general vicinity that was sort of heading straight towards you by coincidence, and so it wouldn't look like it was moving. But yeah, nothing else really sort of comes to mind for that. So that we'll have to send me an email with maybe some more details, some times and things like that, and I'll see if I can check that out. Let's see. Krishna says, I saw Mars and Mercury a couple of mornings ago. Chris, you're down in Texas, right? Yeah. The advantage of being farther south is not just that the air is warmer. I mean, that's certainly a part of it. But also the angles basically tilt up a little bit. And so what that means is that instead of the planets rising and then the sun rises right away, there's more of a space between the planets and the sun rising. So the southern hemisphere had a great opportunity, or the southern United States area and farther south had a good opportunity to see Mercury this time around. Up in the north here, it was a lot harder to see because of those angles being different. And even Mars is still kind of challenging. So if you do head south, you definitely will have an opportunity to get to see the sky in a different way. And if you do head really far south, like down in Texas, you can see stuff that you will not see from here. I did a Texas trip, a number of years ago, and we camped out at Fort Davis near the McDonald Observatory and basically observed all night, every night for 10 days, and it was amazing. But everything looks weird. Actually, even just going to Halifax, they're at about 45, 46 degrees latitude, and here in Winnipeg, we're at almost 50 degrees. Even just that slight change in latitude really makes the sky look weird. Everything's just at slightly the wrong angle. So, okay. Kelly's asking, what is my favorite planet? Well, of course, the Earth. It's where I live. It's where I keep all my stuff. It really is a wonderful planet. My favorite planet to look at, I used to say Saturn, but I haven't seen Saturn for so long. And this last little while, I did get quite a few good views of Jupiter. And then last year, I got good views of Mars. So I don't know. I sort of toss up between those three. Certainly for visual observing, Jupiter is probably the most reliable one because it's big, it's bright. You got the clouds and the great red spot and the moons and things like that. Saturn, when it's visible, you've got the glorious rings. It's hard to go wrong with those two. Wes is asking about a specific telescope there. So the thing about telescopes is the best telescope is the one you use the most often. I have, I'm going to say 3 telescopes because my wife sometimes watches this show. And we'll say 3 telescopes. And basically they're like small, medium, and large. The small one I use sometimes, but it's kind of small. So I only use it when I can't use something else. The medium one gets the most use. Probably 90% of it is the medium telescope because it's powerful enough to do cool things, but it's not a beast to set up. I've got a bigger telescope. When I use it, it is phenomenal. It's only a 10-inch telescope, Wes. So like a 16 inch telescope is an amazing piece of gear. But as you point out, it weighs 144 pounds. And so you're probably assembling it or carrying it or building a trailer for it or something major like that. If you've got a spot where you could leave it in place or just sort of wheel it out from the garage right to the place you're going to observe, like 5 feet or something, it'll be a great scope for you. If you have to move it around or you have to take it apart, or you've got trees in your yard and so you have to sometimes move to the other side of the yard so you can see part of the sky, you're going to get frustrated by it. Or you're going to find that you're only going to use it when you can really spend a lot of time. That's the other thing. If you've got 3 hours of observing and it's an hour setup and takedown, that cuts into your observing time. Whereas I can carry my medium-sized telescope out with one hand, plunk it down, it's set up in about 15 seconds, and then I'm observing that whole 3 hours. So there's trade-offs for big scopes. If it's your first telescope, it's probably overkill for you because you'll be blown away by it, but you would also be blown away by what you would see with an 8-inch telescope, and you would get an easier telescope to use. So I would buy one if I lived where I used to live out of town and I had a beautiful backyard and I could build a little shed to keep it in and I could never have to really move it all that far. In fact, what I'd probably do is build a shed with a roof that comes off, like a little observatory, and just leave it in there all the time because it would be a beautiful scope to look through. I've looked through the 16-inch light bridge and there's it is amazing views of things, but it's a beast. It's a battleship gun. It's massive. So let's see. Callie says, my teacher wants to get a hold of you and maybe you can teach us a bit about Mars. Absolutely. So my email, we have a little thing that is set up through the museum here. That's my email, and drop me a line and I'd be happy to chat with you. Gisa is asking, what is astrology? Astrology is something that started off by people looking at the sky, but instead of using it to sort of, just calculate when winter was coming or, the passage of time, they tried to see if there was a connection between what they saw in the sky and then what would happen here on Earth, big events, or people have always looked for omens and that kind of stuff. It's also it was astronomy up until probably the 1500s, really. Until Galileo started using his telescope, you couldn't really tell the difference between astronomy and astrology because it was all unaided eye observations, and even some of the famous astronomers also did horoscopes on the side to make money because it was basically charting the planets and doing the same kind of math that astronomers did. Nowadays, there are still lots of people that believe in astrology, although there's all sorts of different versions of it, and people have tried to take different versions of different constellations or make modifications so that theirs is more precise or less precise or whatever. Most astronomers nowadays don't really pay attention to that. I mean, and even most astrologers that are actually astrologers kind of put up their nose at the newspaper horoscopes. You know, the odds of 1/12 of the entire world having the same day today is pretty low, right? So that's sort of where that came from. But it does give people an excuse to have a connection with the stars. When I do sky shows, I always ask people what their zodiac constellation is, and I point it out if I can, because they have this feeling that they're connected to it. And that's a great entry point to the sky. So really, really interesting kind of thing. We should do a show on astrology. I don't want to do it like a disproving kind of thing necessarily, but there are some interesting connections between those two things. Anyway, we'll see. I'm working on April, May, June show topics. So if you have ideas for shows, drop them in the chat or send me an email, space@manitobamuseum.ca, and we'd love to know what you want to see. We can do shows on all this kind of stuff. Okay, let us move on to supernovas. Now, this is a topic that we got a couple of requests for, and it fit in this week because this week is actually the 35th anniversary of the discovery of the brightest supernova since the 1600s. It was discovered in 1987, so 35 years ago this week. And the cool thing, well, one of the cool things was that it was discovered by a Winnipegger. So I've got a hometown connection to that. So let's take a look at the supernova. First of all, the specific one, but then also what supernovas are, and then we'll move on from there. So this guy, Ian Shelton, born in Winnipeg, got his bachelor's degree at University of Manitoba, then went on to University of Toronto, and got a great job working at the University of Toronto Southern Observatory. Now, Toronto, if you haven't been there, the University of Toronto has the David Dunlop Observatory, which is a big telescope, like a 74-inch, 72-inch telescope in a big dome in a park in Richmond Hill. And when they built it, you know, back in the 30s or something, Richmond Hill was a dark area. Well, now it's just a suburb of Toronto, and it's totally surrounded by houses and shopping malls and stuff like that. And even back in the 70s, it was not getting to be very dark there. So they were limited. Now, Toronto University didn't have a huge amount of money. They couldn't just, you know, go anywhere, but they managed to get some space in Chile, in the Atacama Desert, and they weren't able to put a major telescope there, but they put a pretty good-sized university one, a 24-inch or 60-centimeter telescope, which was named the Helen Sawyer Hogg Observatory. And for those of you that have watched the show since the beginning, Helen Sawyer Hogg is the person that I basically dedicated the whole first season to, because she's one of my heroes. She was a research astronomer. She did 60 years of research. She was one of the first astronomers in Canada that had her PhD, female astronomers to have a PhD. She did a whole bunch of outreach. She did TV shows and wrote for the newspaper and tried to get people excited about astronomy. Anyway, wonderful person. They named the observatory after her. So there's this little observatory in Chile that is, I mean, frankly, it's not, there are amateur observatories that are almost as good as this thing. So it was a really small as professionals go, but because it was in a great site, they could do some really good stuff. And because it's south of the equator, it could see the southern sky that you couldn't see from Toronto. So it was a nice adjunct to the University of Toronto. This is the kind of view you get from Chile. The southern hemisphere is lucky. They get to see some of the best sights that we can't see very well from here in the north, or can't see at all. The center of the Milky Way, where like all the dust clouds are and where the big black hole is and stuff like that, you can't really get a good view of that from Manitoba latitudes. But if you go down to Chile, it passes right overhead. There's the Magellanic Clouds, two little galaxies that are orbiting the Milky Way galaxy. They're like our little satellite galaxies. You can't see them from here. The Southern Cross, some of the bright constellations. You get better views in the south. Now, of course, there are things that you can't see down there, like they can't see the Big Dipper the whole year. And there are some great objects that they can't see down in the south. But anyway, it was a really, really wonderful place. So Ian Shelton is sitting out there in the Helen Sawyer Hogg Observatory under this pristine sky, and he's taking pictures of the Large Magellanic Cloud, which is one of these little galaxies here. And this was not in the day where you would take a digital picture. This was in the day where you would load a single piece of glass that was coated with film, and you would put it in there, and you would take an exposure that would be like 3 hours long. So he's taking a 3-hour exposure, which basically means he's sitting there looking through an eyepiece, making sure that the crosshairs stay centered on the thing he's looking at, and just killing time, basically. Takes the picture, goes and develops it, and he looks at it, and there's something wrong because there's a big blob where there shouldn't be. So here's the Large Magellanic Cloud here on the left. There's this sort of red-pink spot over here. That's kind of like the Orion Nebula. This is something called the Tarantula Nebula, and it's in the Large Magellanic Cloud. It's a gigantic place where stars are being born. Well, here's that area sort of zoomed in, and right next to it, there was this bright star that he knew wasn't supposed to be there. I mean, you can tell that it's way brighter than anything. If that star was in that spot, he would have known about it, because he had taken this picture many, many times, because he's looking for things that change, stars that get brighter or dimmer, or asteroids that move from night to night. So he sort of knows this area, the sky, like the back of his hand. This star isn't supposed to be there. He develops the film, he looks at it, he doesn't believe his eyes. So he goes outside and just looks up in the sky at the Magellanic Cloud, and he can see this star that doesn't belong. So he confirms to himself that, yes, this is a real thing. It was a supernova, a star that was previously invisible in the Magellanic Clouds, too far away. It would have been invisible to almost certainly to his telescope. Overnight had suddenly got 1 billion times brighter. And that is what a supernova is. So Ian basically became front page news and famous, and just having discovered, it wasn't a supernova in our galaxy, but it was in our nearby galaxy, and it was the first supernova visible to the unaided eye. It actually got bright enough that you could see it from inside the city if you were in the southern hemisphere. We never got to see it here, unfortunately. But Ian was in town, I guess about a year or so afterwards. He came and spoke at the astronomy club, the RASC, and it was pretty cool to hear the story, because he's just like us. Like he's got a PhD, but he just loves the sky, and was just flabbergasted that this thing had happened while he was watching. So I see some questions going on. Yeah, it's a bird nova, it's a plane nova, it's a supernova. Yes. There is, let's see. How long would that have occurred by the time we saw it? Well, the Magellanic Clouds are about 160,000 light years away. So that didn't actually happen in 1987. It happened 160,000 years before 1987. And the light has been traveling that through space that whole time. And it just got to us here on the Earth in 1987. And the supernova was visible for almost 2 years before it faded away completely. And in fact, now we can see a really interesting remnant behind. There's the cloud in the middle. That's the wreckage, the explosive wreckage of the star. Around this, there's this weird ring, and then there's these 2 other rings of material. None of that was there before. These stars, these things with the crosses on them, those are stars, and they were there before. The original star was in the center here, and instead we've got this really weird, intricate ring of material. And it's expanding. So the Hubble Space Telescope was launched in 1990, 3 years after supernova 1987A was discovered, and it's been taking a picture of the supernova remnant every year since then. And they've actually been able to see and track the expansion of the cloud and things like that. Really, really cool. This is a composite image of, it's got X-ray data in there, it's got infrared, it's got visible, it's got radio waves. These little, it looks like pearls on a string here. We think what happened was that the star actually had a ring of material around it beforehand, and the energy going out from the explosion just hit that ring and sort of lit it up in these little hot spots and things like that. But it really is beautiful to look at. Tiffany's asking, Ulrich's, actually, we got a couple of questions here. Okay. Ulrich says, is that a figure 8 ring? You know, it's actually more like an hourglass, and we're looking at it from an angle. So this ring here is kind of like the top face of the hourglass. This would be the bottom of the hourglass, and then the bright ring would be the middle part where it sort of goes in and then goes back out again. So it's kind of a weird perspective, I guess. Tiffany's saying, how long would it take for one to notice a supernova exploding? This is the cool thing about supernova. The universe goes really slow. Like, everything takes forever. We watch, stars live for billions of years. 10,000 years is really fast for a star to do something. Supernovas occur, the really active part occurs in less than 1 second. So literally, you could be watching a part of the sky, and 1 second there's nothing there, and another second there is a brilliant star that has erupted out of nowhere. Now, the odds of that are incredibly low, but still, that's how fast it happens, which is really kind of amazing. So what are these things? Well, they're exploding stars, but that's kind of very broad. There are a couple of different kinds of supernovas. We call them type 1 and type 2 because astronomers are really bad at naming things. Then we realized that type 1 actually was sort of needed some subtypes. So there's type 1a and type 1b and type 1c and type 1d, and then type 2. And then there's type 1-2 that are kind of like halfway between. Those things were based on how they look to a telescope. Basically, how fast they get bright, how fast they fade away, what elements show up in their spectrum when we look at and analyze the starlight. But really what it comes down to is there's a few different ways that a star can go supernova. Supernova 1987A was a blue giant star. Big, bright, massive star. And it only lived for about 11 million years, according to the theory, from its formation, and it burned its hydrogen fuel very, very quickly in about 10 million years, and it ran out of hydrogen pretty much. And the way that stars go, they convert hydrogen into helium in the core, and that's what's making the energy. Well, when it stops burning things, the weight of the star crushes down. But as the weight of the star crushes down, it heats up the middle. And when the middle gets hot enough, it can actually take that helium and burn it and turn it into the next element. And then it does that, and then it runs out of helium. The star starts to collapse, the middle gets hotter, and then it starts to burn the next thing and the next thing and the next thing. It kind of looks kind of like an onion with all these different layers of elements that it can burn. But eventually it gets to, on the periodic table of elements, it gets to iron. And iron, you pretty much can't smash iron into iron and make anything else. It's the end of the fusion train in terms of the energy of a star. And so there's nothing else, basically the fires go out. And so there's no energy pushing out, and there's all the gravity pulling the weight of the star in. And the whole thing just smashes down, but it can't smash down forever. Essentially, it does get to a point where the atoms are pressed up against each other. They can't be pressed anymore. And the outer layers basically hit that atom layer and bounce back. And so that part only takes a second. From that last collapse to the bounce back and the explosion takes a second. And that's what a supernova is. Now there's a bunch of variations of that. Sometimes they're red giant stars. In fact, most of them that we knew before this were red giant stars instead of blue giant stars. Sometimes there's two stars and they're going around each other, and one of them is pulling stuff from the other one and can cause explosions that way. There's all sorts of different ways that these things can happen. But anyway, the one in 1987 let us study a supernova that was pretty close to us with 1987 and modern technology. The previous one that was close to us was in 1604. So there were no telescopes, and there certainly was no way to analyze starlight or anything like that. So really, this was our first chance to see what a supernova really does up close. So there are still papers being published about this supernova 35 years later, because it's still giving us more insights into the deaths of stars and these supernova explosions. Now, supernovas are fairly rare in a given galaxy. You might get, in the Milky Way, you're lucky if you get one every 100 years or so. But if you want to see more supernovas, you just look at 100 galaxies, and you can then see more of them. There's a supernova in other galaxies all the time. In fact, last year, we found over 150 supernovas that occurred. None of them in the Milky Way, but all of them in distant galaxies. And so here you've got this galaxy with a few 100 billion stars and dust and gas and stuff like that. And then you can't even see stars here. They're so insignificant that they don't even show up. But then suddenly one of them explodes. This here is the supernova, and it's brighter than the whole center of the galaxy. Like, what a massive amount of energy being released, again, in 1 second. Kelly's asking, can the sun explode? The great thing about the sun is it's too small for some things, and it's too big for other things. It's kind of in the Goldilocks category. It's just right. It's just right to have enough energy so that it heats up the Earth nicely and it lives for a long time, but it's too small to ever explode. The gravity that it has that would crush down would not allow it to explode. Now, the sun will run out of fuel eventually, 5 billion years or so from now. But what'll happen is just the outer layers will just sort of float off in a big smoke ring, and we'll have a tiny little white dwarf star left. I'm pretty sure that we will have moved on in 5 billion years and have colonized other places or something, because yeah, it would not be a great day to hang around the Earth at that point. But 5 billion years, long time, right? Okay. How does this translate into what we can see in the sky? Well, a couple of ways. First of all, anytime you're out, theoretically, you could see a supernova. Now, again, the odds of that happening are pretty low. But the better you know the sky, the better you have a chance to do this. In 1054 AD, again, way before the invention of the telescope, a new star was discovered in the sky. It was a supernova. It was bright enough to be seen in the daytime, and it was something that was probably made it more significant to some of the ancient peoples. It was in the same zone where the moon and the planets would move. It was in the zodiac. It was actually in the constellation of Taurus the Bull. The Chinese recorded it and saw it for about 700 days before it faded from sight. There is some thought that some of the Pueblo peoples, actually the Anasazi here in North America, recorded it in some of their images here, because the crescent moon and the new star were kind of in that position relative to each other on the first night that it was visible. And I mean, it was so bright that everybody in the world would have been able to see it. So that's kind of cool that it might have been recorded here in North America. Interestingly, the Europeans, there's no really good documented evidence that European sky watchers saw it. Or if they did, they didn't record it or they didn't pay attention to it. Now, 1054, we're kind of right in the middle of the, the Dark Ages, the end of the Dark Ages, the Middle Ages. I think people had more important things to worry about than astronomy at the time. And certainly a lot of records and things like that were lost from those times. But it's possible that Europeans saw it. Maybe it was just bad weather and they didn't see it. I don't know. I mean, if you've been to England, it's not inconceivable that it just rained that whole time and they didn't see it. But, so that was, not quite 1,000 years ago. And so it was basically in the constellation Taurus, sort of right by this star over here. So we're familiar with, here was Orion, here's Beetlejuice, the bright red star, here's Rigel down here. Taurus has the V shape up here. Let's zoom in a little bit. We've got the V-shaped Hyades star cluster. We have the little dipper-shaped Pleiades star cluster. And then we have these two sort of lines out to here. Stars that are big get names, like this star is Aldebaran. Stars that are kind of bright, but not necessarily super bright, often just get designations. So this star over here is called Zeta Tauri. Tauri is, for Taurus, and Zeta is one of the letters of the Greek alphabet. And what they did was they said, okay, Alpha will be the brightest star, and Beta will be the second brightest star, and Gamma will be the third brightest star, and so on. And they just sort of did it that way. So this star is known as Zeta Tauri. Just up from there is the place where the supernova of 1054 exploded. And if you look there now, you will see the dust cloud. Now, this is much closer to us than the supernova 1987A, so that means we get a much better view of the wreckage. So let's take a look at the wreckage of a dead star. You probably won't see it in small binoculars. In fact, even in big binoculars, it's not super noticeable, and you'll need to be in a dark sky because it's fairly faint. But you look at Zeta Tauri, you sort of center your binoculars on that, and then there's a couple of stars nearby that actually sort of stand out in the sky. They kind of make this little triangle here. And just off one side is what's labeled here as M1, also called the Crab Nebula. And it's just a little fuzzy wisp in binoculars. If you have a telescope, you'll get a better view. Here we're using a sort of a small telescope with, fairly low magnification, maybe 20, 25 times. Nothing really big, like your low power eyepiece in your telescope. There's that same triangle, and there's the same little thing. And here, instead of it being a star, there's this sort of little wisp of material. That's called the Crab Nebula. Some guy, Lord Ross, I think, thought it looked like a crab. It really does not look like a crab, at least to me. But this is kind of what it looks like. It's kind of like a little bit of an S-shaped. Actually, it looks like the S from the band Kiss logo. It's sort of like that lightning kind of shape, letter S. That's kind of what it looks like. The star that exploded is not visible, but it would have been right sort of in the middle of that cloud. This is the Hubble image of it, and this is the wreckage of a dead star. And it's basically just that exploded material. Now, this one didn't have a ring around it already, so we don't see those little rings or string of pearls kind of effect. Here, the star was probably a blue supergiant star, and it just blew itself to pieces completely. So this is just this chaotic material. So you can track that down in binoculars or a small telescope. And actually, if you don't have binoculars or a small telescope, you can always watch for Beetlejuice, because Beetlejuice is going to go supernova any day now. Any day in the next 25,000 years, it will explode. I always check it just to see. Now, if it does explode, it will be visible in the daytime. So, I mean, you won't miss it, trust me. But could happen anywhere in the sky. It's kind of cool. This is one of those times where the unchanging heavens really changes very, very quickly. So it's kind of neat to see these things when they do happen. Let's see, other questions. We have, Chris is asking, can Betelgeuse end up as a supernova soon? Yep, any time, like I say. Kepler's supernova of 1054, yeah. So there's going to be, Kepler is one of the astronomers that looked back. There was a supernova in I think it was 1604, and there was also one in the 1500s that he observed. Is a hypernova the same thing? No, it's not really. For a while, the term hypernova was sort of being used to describe a certain kind of supernova that was sort of bigger. It's kind of, well, I think it's fallen out of favor. I haven't really heard it used all that much, but I'll have to look into that. There are so many different kinds of things, and usually what happens, we'll discover something, And then we'll discover another couple of things that are like that something, and we'll say, oh, these things are called supernova. And then we'll discover some things that kind of look like supernova, but they're a bit different. Well, we'll call them supernova anyway. And then it turns out that those slightly different supernova are completely unrelated to the first supernova that we discovered. So these categories that we had based on what we see in the sky rarely stick around long enough to become permanent, because often the actual event that occurs is a different kind of thing. Like, for example, a new star appears. That's what we see. Well, that could be a star exploding. That could be a star that gets bigger and smaller, and it's only visible when it's at its biggest. That could be an actual new star coming into formation, forming from a nebula or things like that. There's all sorts of ways that could happen. And at first, all we know is that there's a new star. So a lot of these naming things get a little confused here. Let's see. Why would a galaxy look like a ring, then to look like a planet? Okay. So galaxies, our collection of stars, are generally in different forms. There's the spiral galaxies that kind of look like the whirlpool effect. And then there are what are called elliptical galaxies, which are just sort of big, round or oval-shaped conglomerations of stars. And depending on the angle that we look at them, they can look like a ring, they can look like a round spot, they can look different because we're seeing them in all different angles and perspectives depending on how they're tilted and things like that. Jeanette's asking, were there any supernovas recorded around 2,000 years ago? There was one in about 393. We think it wasn't actually recorded, but we see a supernova remnant that if you sort of map the growth backwards, it would have been all in one point around 393. That's the one that's closest. We just had, Christmas, and I just, the Christmas star stuff is fresh in my mind. The idea of, the Star of Bethlehem, was that a supernova? We're pretty sure it wasn't a supernova. It could have been something astronomical, but the thing about a supernova is that everybody that looks up at the sky would notice it. Everybody knew the constellations back then. That was your clock, that was your calendar. You had to know at least some basic astronomy. And if there was a big, bright new star there, everybody in the world would have seen it. But then, when the wise men came and talked to Herod actually didn't know about the new star of the Star of Bethlehem. And so that right there tells us that it wasn't a supernova. Anyway, there's a whole nother show that I can do on that because there's some really interesting stuff there. Jamie's asking, do you think there's life on Enceladus? Yep, I sure do. Enceladus, one of the moons of Jupiter and Saturn, pardon me. I also think Europa, actually, around Jupiter. There are so many places where there is water and oceans that we didn't know about before. And I'm pretty sure that we will find life. I don't think we're going to find it on Mars, where we've been looking for, decades. I think we're going to find it in some of these moons of Jupiter and Saturn. Probably very primitive life, plankton, maybe. It would be awesome if it was like squid. I don't know. I think it'd be cool. Something like that. Squid swimming in the oceans of Enceladus. But we'll have to wait and see. Can Beetlejuice become a black hole? It's not likely to become a black hole. It is a very large star like size-wise, but it's not terribly massive. It's very, very sort of thinly spread out. So I don't think Beetlejuice will become a black hole. How do they figure the 25,000-year time limit for the Beetlejuice supernova? Basically from what we understand about star life, we can kind of figure out that certain phases of life take a certain amount of time based on how hot the star is and how bright it is and how big it is and things like that. We kind of put it into our model. And because we understand some of the things of how nuclear reactions go, we can sort of figure out what's going on and do the math. And it's very uncertain, but it gives an idea of the time frame. It's probably 25,000 years plus or minus 25,000 years. I mean, the uncertainties are quite high. But since most things in a star's life are measured in millions of years, 25,000 is actually pretty good. Jenny's going out to check Beetlejuice right now, any minute now. Yeah, exactly. You know what? I would laugh if it does happen. And, you know, I joke about it. It's unlikely it'll even happen in my lifetime, but I still go out and check, you know. I mean, think about it. It would completely change Orion forever. I mean, you'd have this bright star, and then it would be super bright for a while, but then that star would be gone. Like Orion's shoulder, what would his arm connect to? We'd have to redo the constellation. Anyway, fairly minor thing. We have run way over time, and we haven't even done...
Cool space stuff!
So we're going to do this real quick. Although I love chatting. This is a cool picture that I got in my email box. Somebody on the International Space Station took a picture of Mount Everest from space. These are the Himalayas are a massive mountain range where the Indian subcontinent is crashing into Asia. And there's Mount Everest there. That's a cool shot. Have to talk about James Webb. Webb is working. And the Canadian fine guidance sensors, the tracking things, have been used for the first time as they're lining up all the mirrors, and they work perfectly, which is great because that's basically the whole tracking system for the Webb telescope. So that is going to be very, very exciting when that gets up and running. We were going to talk about this more this week, but it's been delayed a little bit. The Axiom 1 mission, the first private mission to the International Space Station, where it's 4 private astronauts, including 1 Canadian guy. They're going up March the 30th for a 10-day mission to the International Space Station. So we'll talk more about that as we get closer to that. And I was going to talk about this as well. You always see pictures like this when we're talking about asteroids, a big picture of an asteroid with the Earth in the distance. Well, this picture is misleading because this asteroid is probably only about the size of your living room. Maybe the size of your whole house. But it's very, very small, relatively speaking. But this last week, we had 2 of these come closer to the Earth than the moon is, significantly closer. In fact, one of them was 10% the distance of the moon, and one was 20% the distance of the moon, which is a pretty close passage. 2 of them in 1 week. You don't want to know how often this occurs. This is only news because 2 of them happened right next to each other. There's pretty much 1 of these a week that comes zooming past the Earth. Sometimes we don't even see it coming until it's already gone past us. I never worry about asteroids, though. I mean, not in a real sense, because space is really big. We're a small target. You really don't have to worry because the odds of something hitting us are less than the odds of Beetlejuice going supernova while you're watching. It's really not a good chance. Now, over the long term, you know, in the next 1,000 years, something will probably hit us. Not enough to like wipe out Earth, but enough to break some windows like that one in Russia a few years back. But you don't have to worry about it. But the cool thing about near-Earth asteroids, it's a very short distance to them if you're going to send a spaceship. So if you want to go and look at asteroids, these ones come right to your back door. And asteroids are made out of some pretty useful things. Lots of rare earth metals and things like that. So there's some private companies, now that space travel is a private company thing too, that are talking about, you know, getting ready for one of these to come zooming by and then launching a spacecraft out to it and then basically mining the material. And then when it comes back around the sun the next time, picking up all the stuff. Anyway, some really neat stuff. We have next week's show will be all about Mars. We haven't talked about Mars in detail for a while. And we're coming into fall in the northern hemisphere of Mars. It's the fall equinox on Mars. So we're going to talk about what's been going on there. And we'll update with all the different rovers and robots and things like that and just see what's going on our neighbor planet as it just becomes visible in the morning sky. Thanks everybody for joining us this week. Sorry we went a little bit long, but there were lots of questions and I really like to get to as many as I can. If there's something that you'd like us to talk about, you can always drop us an email, again, space@manitobamuseum.ca, or you can reach out on the social media on YouTube or on Facebook. Thanks again, And we will see you all next time here at Dome at Home. Thanks for watching.